Hello, everybody, and welcome to another episode of Mental Architecture Building the Mind One Moment at a Time, based off of my book, which is available exclusively on Amazon. Last time we met, I talked about the effects of severe mental illness on time perception, and I also talked about the effects of drugs on time perception. So we're continuing today in Chapter 2, which is No Point in Time, and I want to talk to you about unconscious time. Now, with unconscious time, we're referring to the time passage that you experience while you're asleep or in other states of unconsciousness. So it's really difficult to conduct time estimation studies, kind of like the ones that were done in people who had mental illness or people who were on various kinds of drugs, because time perception during states of sleep and unconsciousness are just highly subjective, and there's really no way to accurately measure them. What we do know is that certain executive memory functions tend to shut down during sleep, which explains some of the time distortion effects. The relationship between time perception and consciousness is so strong that you could almost argue that they're one and the same, and I'll come back to that in a later section of the book or of this chapter. So if you think back to earlier in the chapter, I talked about functional moments, experience moments, and mental presence. Basically, you saw how functional moments built up to these experience moments, which were short little periods of time where you would basically be aware of what you're witnessing and be able to put an ordering to what's happening first, what's happening second, and then mental presence is basically a collection of those experienced moments. We can kind of come back to that idea and ask the question, is the presentation of conscious experience continuous? Does it happen just continuously? So every moment that you're conscious, you're experiencing events in a very smooth flow. And so researchers from the Brain Mind Institute in Switzerland did some studies on this, and they found evidence that time may actually not flow continuously, but instead might flow in what are known as discrete time percepts. So the idea that time occurs in discrete pieces is known as time slices. And so one of the most common examples to suggest that time does not flow continuously, but instead flows in discrete slices is something called the color phi phenomenon. So I want you to take a look at the following image for just a second and observe what you see. Now notice when the red dot turns to blue, in your head you imagine that it's sort of trailing off and somewhere in the middle is changing from red to blue. But in fact, all it is just a red dot changing into a blue dot from the upper left to the lower right. There's really nothing else happening, but your brain fills in the gaps with this illusory motion. And so it's kind of interesting, but that color phi phenomenon shows that your brain does some unconscious processing to make something that's not continuous appear continuous. So what just happened with you when the dot flashed very rapidly and it appeared like there was some kind of motion is an idea known as feature fusion. So feature fusion is basically where things happen so quickly that your brain doesn't process them as two separate events, but rather as a single event. So for instance, if you had a red dot that was immediately followed by a green dot that occurred in super rapid succession, you would just see it as a single yellow dot. You wouldn't see the red and the green. So your brain is not always communicating to your conscious mind exactly what's going on out there. It's kind of weird in that way. And so transcranial magnetic stimulation research, or TMS research, has shown that the threshold for being able to perceive two occurrences as separate, two visual stimuli as separate, is around 400 milliseconds. So anything beneath that will just be fused together. The features will be fused together in a single percept that you'll see as one thing, like the yellow dot, for instance. In an experiment, researchers had subjects view two verniers, which are basically, they look like calipers, and they were presented to them slightly spaced apart, but presented very rapidly. The subjects erroneously perceived that there was only one vernier, not two, even though there were two. And so what the transcranial magnetic stimulation showed was that an area of their occipital cortex favored the first vernier over the second one and just ended up presenting the first one to them, even though the second one was presented to them. Their brain processed just the first one and sort of fused the two together. So there's another example of feature fusion occurring. Another cool example of feature fusion is something known as the cutaneous rabbit effect, where parts on the arm are stimulated in rapid and quick succession, and you feel as if the motion is going all the way up your arm, even though it's only occurring in a couple spots. So check out this video for an example.
All right, hold your arm straight. Good. Turn it like this, wrist up, look the other way. Don't look at the screen, don't look at me. All right, all I want you to do is just remain calm, look over there, all right? And touch your arm a little bit, okay? Okay, can you tell me what I did to your arm? Can you tell me what it felt like? Yeah, where though? Show me. Turn and look. Show me on your arm with your other hand. There. Where else? Show me all the places. Okay, so I touched you. Do that one more time. All the places I touched you. Show me. So I just kind of like went up your arm, right?
Yeah.
Yeah. You know what I actually did?
What?
I only touched right here, and right here. Did it feel like I touched in between there? You know why? Because it takes a little bit of time for information from your skin to get to your brain, 1/10 of a second. So your body fills in the rest of it and makes it feel like something's running up your arm. That's why at night when we brush up against something, we're like, oh, it's a bug, even though it wasn't a bug. Cutaneous rabbit effect.
So feature fusion is everywhere. And another example where feature fusion occurs is in spoken language with homonyms, which are words that are spelled the same but have different meaning. For example, if I told you that I'm going to see the band at the jewelry store after it gets repaired, and then next sentence I said I'm going to see the band next month in concert at the stadium, the word band you couldn't have possibly known what I meant by the word band when you heard me say band, but by the time the sentence is over, it's as if you always knew what the word band meant. So the word band gets fused with the rest of the sentence, depending on the context in which it's being used. And so this is an example where unconscious processing happens faster than you can keep up with it. Now these examples, I think, definitively show you that conscious perception is not a continuous process, but instead it is made up of these building blocks, of these time slices. But how does conscious perception form? What goes on behind the scenes? So researchers Herzog and others conducted some studies to see how it works, and they came up with a two-stage model. And I want to talk to you about that model. But basically, let's think of visual perception, for instance. You have all this sensory data coming in very rapidly. They would argue that within the first 400 milliseconds of you detecting visual imagery, your brain is processing data about object recognition, size, color, hue. I mean, just all the things you could possibly think of are coming together. So I'd like to share a quote with you from Herzog, M.H. Herzog, and you can see kind of what he has to say about feature integration that occurs unconsciously before it's presented to you. Upon completion of the analysis, the features are integrated into a coherent conscious percept. All features become conscious simultaneously, and the percept contains all the feature information derived from various detectors. So there's a lot that has to go on electrochemically in your brain and body for you to be able to see something. The light and other sensory information first comes in through your eye, hits your retina, travels through the retina-ophthalmic tract all the way back to your visual cortex, and then finally information is presented as to what you should see in your mind's brain, basically. It's a lot to take in. Now, Herzog felt that there were three different things that had to happen for sensory perception to occur in an efficient and effective way. Now, the idea here is that you want to avoid feature fusion whenever possible. So you want to be able to separate things temporarily and know what happened first and what happened second. So what Herzog showed is that in one of his models he calls same system, same channel. This is where you have a stimulus that is in the same location. For instance, if it were in the visual field, it would be like dead ahead of you. And those two visual stimuli occur back to back in the same location for Auditory stimuli, the sound source is coming from the same location. Tactile, the tactile sensation is happening in the same spot. So the temporal order threshold, basically, in order for you to be able to tell that these are two different events occurring and not the same one, they're not being fused together. Generally speaking, he found that for visual stimuli, that would be things separated by about 3 milliseconds. For auditory, it was about 10 milliseconds, and for tactile, it was about 25 milliseconds. Now, when things are occurring so close in succession, visually it can seem like flickering. Auditorily, it could also sound very staticky, or I don't know what auditory flickering really sounds like, but that's the best thing I can think of. So for you to be able to not perceive it as flickering, typically the stimuli have to be spaced out by about 16 milliseconds. But I think what makes it easier to order the stimuli that you're seeing or hearing or feeling is just that they're occurring in the exact same spot. Now, when the second characteristic of sensory integration and conscious perception is what Herzog called same system, different channels. And so this would be either two or more visual events occurring in different parts of your visual field, or two auditory events, one occurring maybe near your left ear and the other occurring kind of near your right ear. For the visual, for be able to tell apart and tell the temporal order of the visual stimuli, typically the delay between them needs to be around 20 milliseconds to 50 milliseconds. Auditory stimuli have less of a temporal order judgment threshold because it's thought that the auditory processing equipment that's in your brain is much closer to your ears, whereas your eyes have data that enters through your eyes have a much longer distance to travel to get to your visual cortex, which is at the back of your brain, whereas the auditory cortex is very close to your ears. And so that's why these researchers felt that it was a lot quicker for you to be able to tell apart two noises in two different ears from being able to tell apart two different visual events, which came first, which came second. Still, 20 to 50 milliseconds, that's really, really quick. The third type of temporal order resolution is called different systems, different channels. And so this is your ability to tell apart two different stimuli that occur not only in two different locations, but also two different sensory mechanisms. So to be able to tell apart something you see with your eyes versus a sound you hear with your ears, the research shows that the temporal order judgment is about the same as the previous situation, about 20 milliseconds to 50 milliseconds. And it's not that there's some super timing mechanism in your brain that is able to distinguish different types of sensory data from one another. Well, researchers really don't know why that is the case. So the theory is that all these unconscious moments are kind of filtered and organized together and then presented to you as a conscious experience. But what's unknown is if you experience one conscious experience right after another, or are there momentary, very, very like microsecond moments of unconscious experience separating your conscious experiences. And if you think for a second, well, no, I'm awake and aware during all of this, there's no way that there's any bursts of unconscious activity happening while I'm awake, you might not be correct about that, because if you went unconscious for even 0.00001 seconds, you wouldn't know. It would happen so quickly you wouldn't even be aware of it. But that's debatable. We don't know the answers to that. Let's talk about what we do know. So Herzog likes to compare your conscious experience to the face of a digital watch. So if you look at a digital watch, you'll notice that it says the time, like right now it's 10:07 p.m. And on the face of the watch, it's going to stay 10:07 p.m. until it turns to 10:08 and then 10:09. But in between 10:07 and 10:08, there are rhythmic oscillations going on in the quartz, in the digital quartz. There's a lot going on behind the scenes. But by the time all that's happened, all you see is 10:07 go to 10:08. So he likes to compare conscious experience to all these rhythmic oscillations and things going on behind the scenes that then present you with an image. Not like a camera though. Let me pull out a quote that explains it in with a little more clarity. The comparison of human consciousness to a digital watch is only meant to serve as an oversimplified model of how unconscious processing begets conscious moments. But it does not suggest that these conscious moments occur rhythmically with constant duration. Instead, unconscious processing operates quasi-continuously in the background until it reaches an attractor state. So here's a little food for thought. Your brain is doing tons of unconscious processing, not unlike a computer, and then presents you with its best estimate. That's what the attractor is, the best estimate of what it unraveled out of all that data. So in that sense, what you're seeing is an approximation of what's actually out there. You are seeing the past as your present. You're never seeing what's happening in the present moment. You're always seeing something that's delayed by just a few milliseconds, but it's still delayed. It's still not the present. Now, how long it takes you to make sense out of what you're seeing and hearing around you depends on the complexity of the stimuli. Some things are going to take longer than others to process. One of the things that happens the fastest are your instincts. So if you're in a situation of danger, your fight or flight instinct kicks in very fast within just a few milliseconds. But nonetheless, what is conscious perception? Conscious perception in some ways is seeing unconscious perception in the past as your present. So the conscious present is the unconscious past. It's a really weird thing to think about. It's not fully understood by researchers, but it appears like we see and experience our world in little slices, one slice at a time, pretty much from now until the rest of our lives. Thank you for joining me for another episode of Mental Architecture. Please remember to like, comment, and subscribe below. I will come back next week with another video on the role of imagination in time perception as we start to near the end of Chapter 2. There's only a few more sections to go before we get to Chapter 3. Hope everybody has a great day, and I look forward to seeing you in my next video. Bye!